All right, for section 3.4, part 2, we're not really going to be going over anything very new. The only thing that we're going to add to part 2 is that we're doing partial fractions, and then we're going to go ahead and integrate the answer that we get after we do partial fractions. And also that sometimes we have to do long division before we can do partial fractions. And the times that we have to do long division before we do partial fractions, oh, I lost my pen. Oh, there it is. Okay, the reason that we need to do that, and how you'll know, is we compare the degree of the numerator with the degree of the denominator. So in this case, this example number 1 that we have, notice that the degree of the numerator is 3, and the degree of the denominator is 2, so this is 3. Degree down here is 2, so anytime the degree of your numerator is more than the degree of your denominator, then you're going to have to start off with long division. So you're going to do long division first, then your remainder, depending on what your remainder is, you may or may not have to continue on with partial fractions. There is one problem in your homework assignment where all you do is long division, and then you can go ahead and integrate right after that. But sometimes you do long division, depending on what your remainder is, you may have to also incorporate partial fractions in with that. So we're going to go ahead and start with example number 1. As we just talked about, we're going to have to start off with long division. Then we'll just see what happens from there as to whether or not we have to do partial fractions along with that. So I'm going to pause here for a second, and then I'll reset here example number 1. Okay, we are going to start off with long division. So we have x squared, and I'm going to put in a placeholder here. So remember, when we did long division, we need every term. Let's put a plus 0x. It doesn't really matter, but plus looks better. Minus 25, and inside is going to be 4x cubed plus 3x squared minus 97x minus 80. Okay, so first step here, we're going to ask ourselves, what do we need to multiply to x squared to get 4x cubed? And that's going to be 4x. So 4x times x squared is 4x cubed. So that's perfect. And then just have to multiply to everything. So 4x times 0x is 0x squared. 4x times negative 25 is going to be negative 100x. And then we're going to draw our line and change all of our signs. Add down, those cancel. 3x squared minus 0x squared is still 3x squared. Negative 97x plus 100x is plus 3x. And then bring down the negative 80. All right, next, what do we multiply to x squared to get 3x squared? And that's a plus 3. So then multiply and distribute that through everything. So we have 3x squared plus 3 times 0 is 0, so plus 0x. And then 3 times negative 25 is negative 75. Draw your line, change your signs. So those first ones cancel. 3x minus 0x is 3x. Negative 80 plus 75 is going to give us a, minus. So go back. Is going to give us a minus 5. Okay, so we did our long division. We come up with 4. Our answer is going to be 4x plus 3 plus our remainder over the divisor. So 3x minus 5. So with our remainder, remember we need to put that over what we divided by, or we could use this one up here since it's a remainder. So that's going to be x squared minus 25. Now we have to decide if we need to continue on with partial fractions or if we can go directly to integration. So in this case, we have x squared minus 25. It is a quadratic equation, but we can factor it. So let's rewrite that as 4x plus 3 plus 3x minus 5 over x minus 5. Oh, yes, thank you very much. All right, so x minus 5. Okay, x minus 5 and x plus 5. Okay, so we are going to be able to do, or we need to use partial fractions for that second part, and when we integrate, that's going to look like this. So we're going to integrate 4x plus 3, so we can integrate those terms just fine, and then plus 3x, well, let's rewrite those in integration terms, or partial fractions. So we don't know what these are going to be yet, so I'm just going to say a over x minus 5 plus b over x plus 5. Now we need to figure out what a and b are going to be. So we have 3x minus 5 over x minus 5, x plus 5, and that is going to equal a over x minus 5 plus b over x plus 5. So with partial fractions, we want to be able to split that fraction into two separate parts. So go ahead and multiply both sides by the denominator of the left-hand side. So that is going to give us 3x minus 5 is equal to a times x plus 5, which is going to be ax plus 5a. And then we're going to multiply this b by the x minus 5, so plus bx minus 5b. Now let's order our terms so we can compare coefficients. So we'll have a plus b times x. So I'm putting these two in order here. We have ax plus bx. Factor out the x, and I get a coefficient of a plus b, x. And then for our constant, we have 5a minus 5b. Now, comparing coefficients to the left-hand side and the right-hand side, the x coefficient is 3 on the left-hand side, a plus b on the right-hand side, so we know those have to equal each other. So we have a plus b equals 3, and 5a minus 5b equals negative 5. So we need to use those two equations together. I need to get myself some more room over here, so we can work here. And so we have the equations a plus b equals 3, and then we also have 5a minus 5b equals negative 5. So I can take this equation here, multiply it by a 5, and then add the two equations together, and my b's will cancel. So that would give me 5a plus 5b equals 15. And when we add those together, we will have 10a, my b's will cancel, equals 10. Therefore, a equals 1. And then come over here, well, you're going to use the equation that's inside the parentheses. So 1 plus b equals 3, and therefore b equals 2. All right, so now I'm going to go ahead and write these up here, and then I'm going to give myself a lot more room here, and we'll go ahead and continue on with our integration. So now we know that a equals 1, b equals 2, so we can use this integration equation right here. We're going to complete that with the a and the b, and then we're going to integrate. So I'm going to pause, erase a bunch of this, and then I'll be right back. Okay, so now we are ready to integrate. We want to integrate this formula right here. So 4x plus 3. We now know that a is 1, because that's what we just found. So 1 over x minus 5 plus b, which is 2, over x plus 5. And dx. Okay, so integrating that, we are going to get 4 over 2. So 4 divided by 2 is going to be 2x squared plus 3x. This here is going to give me the natural log of the absolute value of x minus 5. Plus, we can bring that 2 out in front. So 2 times the natural log, the natural log of the absolute value of x plus 5, and then plus a c. And then that's our final answer for example number 1. Now, a couple of things here to watch for. In this case, this was a nice simple one. I had no coefficients to my variables in the denominator, so I did not have to worry about any type of a chain rule or u substitution for either one of these. Neither one of them were squared. If we had 2 over x squared plus 5, that's going to turn into an arctangent. So be really careful with what we have. This one was nice and simple, very straightforward, no u substitution that we needed to use, no arctangents came into play. So this was a fairly easy one, other than the fact that we had to use long division and partial fractions before we could ever even integrate our equation. But everything worked out great for this one. That's our example or answer for example number 1. And I'm going to go ahead and end this video here, move on to example 2 on the next video.